So far we have seen body plot and gain margin, phase margin. And then we have seen how to adjust K by using body plot. Now we are going to see polar plot and Nyquist plot. To understand Nyquist stability criterion, first of all, we must know what is mapping. What is mapping? Mapping means, suppose I'm having S-plane. This is S-plane, am I correct? Since its axis is omega, x-axis is omega, y-axis is, sorry, x-axis is sigma, y-axis is j omega. Therefore, it is the imaginary plane, complex plane, that is S-plane. Complex plane is called S-plane. In that S-plane, you are taking one point, say S1. Take S1 and substitute in Q of S. Q of S equal to a transfer function G of S, that is 1 by tau S plus 1. That S1 point is substituted here. What is that point? A complex point. Am I correct or not? That complex point, let it be minus 2 plus J3. S1 is minus 2 plus J3. Substitute here minus 2 plus J3. Final number again complex number. Am I correct or not? If you substitute a complex number, again you will get a complex number. Plot it on a complex plane, another complex plane. This is another complex plane. Another complex plane. This complex plane is called G of S plane. Why? Because I substituted this S plane point on G of S and I got one complex number that is plotted here in the complex plane. That's why this plane is not S plane. This plane is called the G plane. I am taking Q of S. Q of S equal to 1 by Ts plus 1 or 1 by 5S plus 1. In that, what is the taken point? Minus 5 multiplied by minus 2 plus J3 plus 1. If you simplify this, again, you will get a complex number. Again, you will get a complex number. To convert this into complex number, you will multiply the numerator denominator by complex conjugate so that the denominator becomes a real number and the numerator becomes complex number. That and all you know. So anyhow, what we know that this is a complex number. That complex number is this. This complex number is this Q1. S1 is substituted in Q. You got a complex number Q1. Like that, I can take many points. S1, S2, S3, S4, S5, S6. Like that, I am taking many points and substituted in Q of S. I will get Q1, Q2, Q3, Q4 like that. I plotted here. I plotted in another plane called the Q plane. Why it is called the Q plane? Because the S plane point is substituted in the function Q and I got complex numbers. That's why this plane is called Q plane. Q plane. If the S plane points are substituted on a G plane, transfer function G, then this plane is called G plane. Suppose I am substituted all these points, S plane points, set of S plane points are substituted on G of S, H of S, then this plane is called GH plane. GH plane. That is called mapping. That is called mapping. I mapped this S1 in Q plane as Q1. Suppose I am taking one contour. Contour means closed path. Mathematics, contour means closed path. I am taking a contour C. I am taking many points on the contour, S1, S2, S3, S4, etc. I am doing mapping on Q. I am doing mapping on Q. It means what? Hereafter, I won't say substitute those points on Q and find those values. I won't say. Simply, I say you are doing mapping of that contour. It means taking many points on the contour, substituted in Q, and it is plotted on Q plane. So now we are having two planes. One is S plane, another one is Q plane. In the S plane, I am having a contour. I am having a contour C. I am selecting many points on the contour that is substituted on Q of S. I got many complex number. The first point minus 2 plus J3 is substituted. You got 1 by J3 or minus J.33. That point is plotted here. That point is plotted here. Like that, I selected many points and substituted. I got a contour here. I got a contour here. Suppose I'm having a pole of that Q of S inside that contour. I'm having a contour C. This is the contour in S plane. This is the contour in S plane. The contour is selected such a way that the pole is inside that contour. The pole is inside that contour. I have selected the contours such a way that the pole is inside the contour. If I do the mapping, how to do mapping? Select many points on this contour and substituted in this G of S, GH of S, GH of S. You got many points. GH1, GH2, GH3, GH4, like that. I plotted all these points. You got this mapping. This is the mapping. Mapping of C contour on GH plane. Mapping of C on GH plane. You notice that this mapping is encircle the circle in the anti-clockwise direction one time. So if the pole is inside that contour, that is mathematics. That is mathematics. So if a pole is inside the contour means, if you do the mapping, it will encircle the origin in the anti-clockwise direction. How I am telling the direction? If you select S1, S2, S3 in the clockwise direction, here Q1, Q2, Q3 will move like this, like that in the anti-clockwise direction. Therefore, if the contour encloses the pole in the clockwise direction, then this mapping will encircle the origin in the anti-clockwise direction once. Suppose I am having two poles inside. I am having two poles inside the contour. If I do the mapping, it will encircle the origin twice. I can say like this. It encircle the origin twice. It encircle the origin twice. It encircle the origin twice. If two poles are inside, that is mathematics. The in the S plane, this is S plane. This is S plane. This is Q plane. You are doing mapping, selecting S1, S2, S3. You are selecting many points on the contour and substituted in Q of S. You got points, many points. That is Q1, Q2, Q3, like that you got. If you plot all points, you will get a contour. It will encircle the origin twice in the anti-clockwise direction because you are taking this contour in the clockwise direction. Suppose I am having no poles inside. All poles are outside. The pole is outside. The poles are outside. I am selecting a contour. If you do the mapping, it will not encircle the origin. It will not encircle the origin. The mapping is outside. The Q plane, if you see that, the mapping is outside. Suppose I'm having 1, 0 inside. I'm having 1, 0 inside. So far, pole we have seen. You are doing the mapping in the clockwise direction. You are doing the mapping in the clockwise direction. The mapping will be also in the clockwise direction. The origin will be encircled in the clockwise direction. For pole, it encircle in the anti-clockwise direction. For 0, it encircle in the clockwise direction. Suppose I am having two poles and 1, 0 inside. It will encircle only once. One pole and 1 0 will be getting cancelled. The difference only it will encircle. The difference is only 1 pole. That's why it will encircle the origin in the anti-clockwise direction once. But you are doing, the contour is selected in the clockwise direction means it will encircle the origin in the anti-clockwise direction once. Suppose I am having two zeros inside and one pole. What will happen? These two are getting cancelled. These two are getting cancelled. It means the difference is 0 only exceeds. That's why it will encircle in the clockwise direction. It will encircle the origin in the clockwise direction. That is the fundamental for Nyquist plot. Now, by having this fundamental, we can understand the Nyquist stability criterion. Nyquist stability criterion. I'm having a Q of S is equal to 1 plus G of S H of S equal to 0. What is 1 plus G of S H of S equal to 0? 1 plus G of S H of S equal to 0 is what? Characteristic polynomial. Denominator polynomial of a closed loop system. Am I correct or not? You see that closed loop transfer function? 1 plus G of S H of S. 1 plus G of S H of S in the denominator. For that, we are going to do the mapping. That is Q. That is Q. It means what? We are substituting the set of points on 1 plus G of S H of S. If any zeros inside that contour, it will encircle the origin once in the clockwise direction. Suppose I am selecting a contour such a way that the entire right hand side plane is taken. The entire right hand side plane is taken. It means I am taking up to J infinity. Here I am taking up to minus J infinity. I am taking a circle of radius infinity. It means what? The entire right hand side plane is taken as contour. All points on the contour is substituted in Q of S. You are doing the mapping. You are doing the mapping. If any poles on the right hand side, it will encircle the origin that many times. If doesn't encircle, it means no poles on the right hand side. No poles on the right hand side. That's why the system is stable. No poles, no zeros on the right hand side. Therefore, the system is stable, we can say. Suppose I am having characteristic equation, not Q of S is not a transfer function. It is a characteristic equation. Characteristic equation means you can simplify this like this 1 plus, suppose I am having G of S, H of S equal to 1 by tau S plus 1. If you take LCM, what you will get? Q of S equal to what? Q of S equal to characteristic polynomial will be tau S plus 1, tau S plus 1 plus 1. That is numerator become tau S plus 2. Am I correct or not? The numerator is the characteristic polynomial. Am I correct or not? Because characteristic polynomial you are equating to 0. That's why the denominator becomes 0. We are assuming we are taking only numerator. If we take the characteristic polynomial, we should talk about the numerator of Q of S. The numerator, that is zeros of Q of S should not be on the right hand side. Am I correct or not? Very difficult to digest. Because so far we have seen that the pole should not be on the right hand side. But for Q of S, that is 1 plus G of S, numerator is the denominator polynomial. You see 1 plus G of S, H of S, take LCM and equate to 0. This becomes numerator only. Characteristic polynomial means numerator only. What is characteristic polynomial? It is nothing but denominator polynomial of closed loop system. Therefore, the zeros of characteristic polynomial means it is closed loop poles. Zeros of characteristic, this line alone you remember. This line alone you remember. Zeros of characteristic polynomial are closed loop poles. Zeros of characteristic polynomials are closed loop poles. In other words, zeros of Q of S are closed loop poles. Zeros of Q of S are Q of S equal to what? 1 plus GH. The numerator of 1 plus G of S, H of S is the characteristic polynomial. Therefore, zeros of Q of S are closed loop poles that should not be on the right hand side. That's why if you do the mapping, it is not yet over. Nyquist stability criterion is not yet over. What we have taken 1 plus g of s, h of s equal to 0. Instead of taking like that, add minus 1 on both sides. What you will get? G of s equal, h of s equal to minus 1. Am I correct or not? If you see 1 plus g of s, h of s equal to 0 means whether you are encircling 0 or not. 0 is replaced by minus 1. That's why whether it encloses minus 1 or not, we have to check, not 0. So if you check for g of s, h of s, if you check for g of s, h of s, it should not encircle minus 1. It should not encircle minus 1. That is Nyquist stability criterion. 0 is replaced by minus 1. 0 is replaced by minus 1. That is, you are shifting the plot about 0 to about minus 1. That is the meaning. That is the meaning. If you shift the graph about origin to about minus 1 means we need not check whether it encircles 0. Instead, we have to check whether it encircles minus 1. But if it is checked for minus 1, whether it encircles minus 1 or not, if we check, then we can check directly for open loop transfer function. No need to go for closed loop transfer function. Because we are not checking for origin. We are checking for minus 1. That's why we can check for g of s, h of s. We can check for g of s, h of s.